distinction between alkyl cyanides and alkyl isocyanides. Important to understand the structure of alkyl cyanides and alkyl isocyanides. This is alkyl cyanide and next one is the alkyl isocyanide. Observe that in alkyl cyanide, alkyl group is attached to carbon atom of CN group and nitrogen is present at the end, while in alkyl isocyanide, alkyl group is attached directly to the nitrogen atom and carbon is present on the other end, the free end. Therefore, the two compounds behave quite differently towards hydrolysis and reduction, which are main distinguishing reactions between the two important groups. Important to know that MIC, methyl isocyanate, is industrially prepared by the action of methylamine with phosgene gas. This is CH3NH2 plus COCl2. Phosgene gives an intermediate compound which on heating liberates HCl to give CH3NCO. This is methyl isocyanate. Cyanides have more polar characters than isocyanides. Hence, cyanides have high boiling point and are more soluble in water. However, both isomers are more polar than alkyl halides. Hence, their boiling points are higher than the corresponding alkyl halides. Being less polar, isocyanides are not attacked by hydroxyl ions. Cyanides and isocyanates are analog of cyanides and isocyanides. Isocyanates are found to be important intermediates during several common reactions like Curtius reaction, where the heating of an acyl azide to form isocyanate. Acyl azide is heated to give an intermediate compound where further rearrangement give the corresponding isocyanate. Next, the Schmidt's reaction. Here, the reaction of carboxylic acids with hydrozoic acid in presence of concentrated sulfuric acid gives the corresponding acyl azide. The reaction is the carboxylic acid when treated with ammonia in presence of sulfuric acid gives the corresponding acyl azide as RCON3. The next is the Lausanne's rearrangement reaction. Here in this reaction, hydroxamic acid with base. Hydroxamic acid when treated with the compounds like KOH or NOH gives an intermediate compound which further rearranged to give corresponding isocyanate. The next is Hofmann rearrangement reaction. The reaction of an acid amide with bromine or chlorine and alkali. In all these cases, alkyl isocyanates are converted into amines by reaction with alkali. The next group of compound is amines. Amines may be regarded as derivatives of ammonia. Basically, there are three types of amines: primary amine, secondary amines and tertiary amines. Depending upon the number of alkyl groups attached to the nitrogen atom. For example, CH3NH2, this is methylamine, a type of primary amine. CH3 whole twice NH, this is dimethylamine, a type of secondary amine. CH3 whole thrice N, this is trimethylamine, type of tertiary amine. And the next one is C6H5NH2, this is aniline, this is aromatic primary amine. Amines are named as alkylamines, aminoalkanes, or alkane amine, the last being the IUPAC name. For example, the C2H5NH2, this is ethylamine or aminoethane. Next one is the CH3NHCH3, this is dimethylamine or N-methyl aminomethane. Next one is the CH3NCH3 C2H5, this is ethyl dimethylamine, N-dimethyl aminoethane. Cyclic amines are named as cycloalkane amine. For example, cyclohexanamine and ethyl cyclopentanamine or N-dicyclopropyl cyclopentanamine.